fairly routine combinatorics problems. I think of combinatorics as just the math of counting. I think it has a broader definition in a discrete math course. But again, I'm just going to call this a combinatoric. And again, I interpret this as the math of counting, combinatorics. Okay. And this is similar to a Singapore Math Olympiad Junior 2019, problem 18. Theirs was a 5-digit number. I'm just dealing with 4-digit numbers here. It's a little easier that way. Now we're given two conditions on our integer n. It has to be strictly greater than 4, 5, 6, 7. And it has to be comprised of the distinct digits from the set 3, 4, 5, 6. And so, of course, about the only question you can think of here is how many possible n would meet these two conditions. And we make a very obvious, the leading digit can't be 3, obviously, because that would be certainly less than this number. Okay, so we can rule that out. And also these two that begin with 4 are less than 45, 67. Right here you see 45, 67, 45, 67, these two. But we can rearrange it ever so slightly to 4, 6 in the first two positions, which any 4-digit number with these two digits in the first position is going to exceed 45, 67, right? So I'll just put 2 blanks out here. And there's exactly 2 factorial ways to fill in the blanks. In other words, we've already consumed the digits 4 and 6, and so we would have to pick between the digits 3 and 5. Okay, like you'd have 3, 5, and then 5, 3, and I'm just putting 2 factorial. That's the way you count. Okay, so we've taken care of everything through 3 and 4 is the leading digit. Now, so the next natural is certainly any digit, any 4-digit number that begins with 5 is going to meet the requirements, but it's going to have 3 blanks. Okay, and of course 3 factorial ways to arrange. And y'all, I just there's 3 ways to choose this digit, 2 ways to choose this digit, and 1 way to prove that choose this digit. And that they call it, I think they call it the fundamental counting principle or something, but you just multiply the possibilities together. Okay, and then the last possibility here, since 6 is the last permissible digit, is the very same thing except 6 is our leading digit. So we get 3 factorial here. And these are clearly exclusive conditions here. They can't overlap. There's no intersection of anything here. So this is equal to 2. This is equal to 3 times 2 times 1, which is 6. Same thing here. And when you sum these up, you get 14. When you add these up, you get 14. And that's the answer I got, folks. And I think this is correct. But, combinatorics has always been slippery for me. Even when I'm sure, I overlook something. So I won't even rule out the possibility. I don't think I've ruled out anything, but I missed anything. But I very well could have, because these things, some of the cases get by me quite frequently. But anyway, the answer I got was 14. So how many possible n? 14. Thanks for being